Okay, this video is about solving quadratic inequalities. So in the previous videos, we've been looking at solving quadratic equations. So the difference in an equation and an inequality is the sign. Instead of an equal sign, we'll have something like greater than and less or equal to or less than or equal to. These are inequality signs. And so this is, for instance, what a quadratic inequality looks like. If we have something like this, x squared plus 2x minus 35 is less than or equal to 0. This is a quadratic because it's x squared. It's an inequality because it has this less than or equal to sign. And so in order to solve this, I'm going to solve this graphically. And so we're going to build on what we've been learning, which is how to solve quadratic equations. We've learned how to do it by factoring, by by taking the square root, by completing the square, and by quadratic formula. So in order to solve this, this is the process I'd like us to use. We're going to find, number one, we'll find the zeros. And so if you will recall that zeros are x-intercepts, that's what we're interested in. And so to find the zeros, we'll change this from less than or equal to 0 to equal 0. So we're going to replace that with the equal 0. Number two, and so we'll solve. We're going to set it equal to 0 and solve, okay. And then, this is the thing, if a, which is the leading coefficient, if a is positive, then we're looking at a parabola. That's the shape of a quadratic function, a parabola that's facing up. If a is negative, we're looking at a quadratic equation that's facing down. So we're just going to, after we solve this, this gives us two answers. X is equal to whatever, and those are x-intercepts. And so we're going to use that information. So first we're going to find the zeros. Second, we're going to sketch it. Sketch the graph. And thirdly, we're going to interpret and answer the inequality. I'll just say inequality. All right, so let's just run through it for this first one. At first, we're going to solve, we're going to set this equal to 0. So let's set x squared plus 2x minus 35 equals 0. Let's solve this. This one will factor. A times c is negative 35. We want two things to add up to be 2. Positive, negative. How about 7 times negative 5 is negative 35, and 7 minus 5 is 2. Since the leading coefficient is 1, we can say this is x plus 7, x minus 5 is 0, okay? This gives us x is negative 7 and x is 5. These are the roots, solutions, zeros, x-intercepts. These are x-intercepts. Let's think about that. Let's go to step 2. Let's sketch the graph. Okay, this is just a sketch. It's not super accurate, but here we go. This is a positive leading coefficient, which means that I'm going to have a parabola that's facing up. It's going to pass through over here at x is negative 7 and over here at x is 5. Somehow it's going to be some parabola that is going to be like this. Now why did we sketch it? Because now it's super easy to go back up here. Step number 3, let's answer this inequality. What we're supposed to do is, this says write down all the x values where this parabola is negative or equal to 0, less than 0, negative or equal to 0. Where is that happening? That's happening from this point. This is where it equals 0, and down below the y-axis is where it's negative. So how we answer this question is say from negative 7 to 5. That's how we will solve that inequality. All right, let's do a second example. How about this? Let's solve x squared minus 15 plus 44. X squared minus 15x plus 44 is greater than 0. Okay, here we go. We want to find the 0. So we're going to set it equal to 0 and solve. So x squared minus 15x plus 44, okay, equals 0. We're going to set it equal to 0 and we're going to find the x-intercept. Right? I think this one might factor too. So let's just see if we can get this to factor. A times c is 44. We want two things to add up to be negative 15. In order to multiply to be a positive but add to be a negative, we could say negative 11. 11 times 4. 11 times 4 is 44. So negative 11 times negative 4 is 44. This plus this is negative 15. So let's see. X minus 11. X minus 4 is 0. We get x is equal to 11. X is equal to 4. So we can graph this. This is going to be facing up. Oh, but this time it's going to be over here. Maybe this is x is 4. Maybe this is x is 11. And remember, this is a sketch. It doesn't have to be super accurate. But it should be enough for us to be able to answer the question. What is the question? We're ready here. Interpret and answer the inequality. Okay. Write down all the x values where this parabola is greater than 0, is positive, where it's above the x-axis. So that means here and here. Don't include where it's touching the x-axis because there's no or equal to. How will we write that? Well, this is from negative infinity all the way to x is 4, negative infinity to 4, and then don't talk about this part where it's down here below. Then we're going to union this with 11 to infinity. So that will be our answer for number 2. All right, number 3 looks like this. It is 121 is minus x squared is less than or equal to 0. 121 minus x squared is less than or equal to 0. Yeah, that's what I have. Okay, so what should we do? Let's solve it. Let's set it equal to 0 and solve. 121 minus x squared equals to 0. So I'm going to add x squared. So I'll get 121 is equal to x squared. And if I want to think of it as x squared as 121, that's fine. I'm going to take the square root of both sides. That's why I decided to do that. So take the square root of both sides. Square root of x squared is just x is equal to plus or minus the square root of 121. X is plus or minus 11. So here are my two answers. X is 11, x is a negative 11. So this is 11, this is negative 11. Now, here's my parabola. It is negative x squared. Negative a means it's facing down. So this parabola is going to be some kind of parabola that looks like that. This is kind of going out a little bit. Okay, this is my parabola. And it's hitting the x-axis at negative 11 and positive 11. And so now we interpret and answer the inequality. This says for what x values, write down the x values where my parabola is less than 0, negative, or equal to 0, touching. Well, that means here's where it's touching, and here's where it's negative. Okay? What are those x values? From negative infinity to negative 11. Don't talk about where it's positive. Union it with positive 11 to infinity. The reason I'm writing brackets is because it had or equal to, and that means I want to include those points. All right, that's how we would answer number 3. Number 4 looks like this. Solve x squared is greater than 16. X squared is greater than 16. Okay. First, we're going to set this equal instead of greater than. So x squared equals 16. I can take the square root of both sides like I did in the last example, but just to show you other examples, I'm gonna get a 0 on one side, and I'm gonna choose to factor this. X plus 4, this is difference of squares. X minus 4 is 0. So I solve and I get x plus 4 is 0, or x is negative 4. X minus 4 is 0, or x is 4. And I get these zeros, these x-intercepts. And so Right here, we want to get a 0 on one side because it's easier to solve. So let's subtract the 16. X squared minus 16 is greater than 0. This is what we want to solve because it's real easy to look above the x-axis and below the x-axis when you have a 0 right there. This parabola is facing up, okay, and it looks like it's going to pass through -4 and 4 because these are the zeros, okay. So it's going to go here and here. This is what it's going to look like. This is -4 and this is 4. Now we need to simply answer the question. The question is, for what x values, where is this parabola positive above the x-axis? Don't include where it's touching the x-axis. So that means right here we need open circles and we need to include where it is above. So this is for what x values. This is going to be from -infinity to -4, union it with 4 to infinity. That is what this is going to look like. All right, we've got 2 more examples and then we'll be done. How about this one? 4x minus 4 minus x squared. 4x minus 4 minus x squared is less than 0. Okay, this is what we're solving. Now, first, let's set up an equation. So let's solve this guy. 4x minus 4 minus x squared equals 0. Let's solve this. I don't like to work with the negative leading coefficient when I'm solving, so I'm going to divide both sides by -1. You're allowed to do the same thing. So this would be -4x plus 4 plus x squared is 0. I'm going to rearrange my terms into x squared minus 4x plus 4 is 0. You can use quadratic formula, completing the square, or factoring to solve this. I think this factors into x. I need 2 things to multiply to be 4, but to add to be -4, that's going to be a -2 and a -2. X minus 2 is 0. Or x minus 2 squared is 0. Take the square root of both sides. X minus 2 is 0. X is 2. Or just set each one of this equal to 0 and solve. You get x is 2, x is 2. This is a double root. This is a situation where if we took the discriminant would equal to 0 and it would say you get 1 real root. That's what's happening here. So right here, x is 2. All right, fine. This is what we're supposed to solve. This is a parabola. This is facing down. Got a parabola facing down. Where is the x-intercept? There's only 1, and it's hitting at x is 2. So this is what the picture of this guy looks like. Here's 1, here's 2. This is a parabola whose only has 1 x-intercept because it's only hitting at 2. That's what's happening here. This is known as a double root. Now, we have to answer this question. Where is this parabola negative? Below the x-axis. Well, lots of places, almost everywhere. So it is negative here and here. And the only place it's not negative is at 2 where it's equaling 0. So if this had a or equal to, we would include every x value, but it doesn't. So we're going to include every x value except where x equals to 2. So it goes like this. From -infinity to 2 and 2 to infinity. That is the answer to that one. Okay, last one, and then we're done with this. How about this? Solve x squared plus 18 is less than 8x. So we need to get a 0 on one side because that's an easy way to answer inequalities, above or below the x-axis. So let's move this 8x over here by subtracting. X squared minus 8x plus 18 is less than 0. Then we'll convert this to an equation and solve it, okay? So let's solve this guy. X squared minus 8x plus 18 is 0. Let's see, 18, does this factor? We need 2 things to multiply to be 18, but add up to be -8. Let's see. 9 times 2 would give me 7. 6 times 3 gives me 18, but that adds up to be 9. I'm going to have to use, I can't factor this one. Let's use quadratic formula. X is negative, the A is 1, B is negative 8, C is 18. Negative B plus or minus the square root of B squared, 8 squared is 64, minus 4 times 1 times 18, all over 2 times A. All right. X is 8 plus or minus the square root of 64 minus 18 times 4 is 32. 4 is 72. 72 over 2. Oh my goodness. My discriminant is negative. Let's see. 72 minus 64. Negative 8, I think, over 2. But the fact that the discriminant is negative means my zeros are going to be imaginary. What that means, how does that relate to graphing, is they do not touch the x-axis. Imaginary roots do not show up as intercepts. Only real solutions show up as x-intercepts. So what does that mean? Let's look at this. What that means, this is how we will interpret this parabola. This has got a positive A. This is facing up. It's going to be a U-shape facing up. But it doesn't ever touch the x-axis. So wherever it is some parabola that is facing up, and it never gets low enough to touch the x-axis. That's basically what we're looking at. So how do we answer this question? For what x values is this parabola, where is this parabola lower than the x-axis? It's already facing up. It won't touch this x-axis, so it's never going to be negative. So there's no solution here. No solution here. So what if, here's a what if scenario. What if I change this problem slightly and this was facing this way? So I've changed the color to indicate this is a new, I'm messing with the problem now. Okay, this part does not change. This is what it equals to. The discriminant is negative. It's still got imaginary solution. It's got imaginary roots, and so it never touches the x-axis. But what if we're trying to answer this question? Where is this parabola positive? Where is it above the x-axis? Here it is. It's always positive. It's always above the x-axis. So from when x is negative infinity to positive infinity is how we would answer that scenario. So that is basically quadratic inequalities.